Stickman Walking Virtual Lab. So here are the instructions. Make sure before you do this lab that you've done your Lesson 3 note sheet. Part 1, you're going to look at this sketch, a distance versus time graph, and we have, 5 different people, their graphs, right? So we have person E, person D, person A, person B, and person C. And you're going to answer questions about them. So we'll do one together here. Which person is walking the fastest? So you have to think, and you'll know from your Lesson 3 note sheet, the person that's going the fastest is going to cover the most distance in the shortest amount of time, right? So here we see person E has a steep slope, right? That indicates a fast speed, right? Meaning that as this much time has gone by, right? They've gone far. They've gone farther than anyone, right? They've gotten all the way up to here. Now we don't have units here on our distance or time, so these are just kind of rough sketches. But person E is the one that has gone the fastest. So you can just type that in there, and then you'll answer the other ones. For this part of the virtual lab, you're going to open this link here, and it's going to take you to a screen that looks like this, and you're going to, the screen that it will take you to will just have the red line. Here, I'll show you what it looks like here. There it is. So it'll have it'll take you to puzzle number 1. We're going to start with puzzle number 2 here, so we can click through the different puzzles by using the arrows. We'll start with puzzle 2, and then you move this little stick person along the line at a rate that will make your graph match the red line. Now, it's not working on my iPad to move the stick person, so what I did is I just did a screenshot of how I did it on my computer with my trackpad. So here, the red line is what's given. And then as you take your person, the person starts over here, and you move that person at a rate that will make this blue line here, you try to match it to the red line. So you can see I did pretty good. I got it pretty close to the red line. I kind of slowed down a little too much right here, and so I sped up a little bit more, but I overcompensated. Then I was going too fast, and then I just stopped. So I was doing pretty good for the first part. So you try to match it. It doesn't have to be perfect. Don't spend too much time on it, but it will give you a score. You'll get a higher score the closer you match it. And then you're going to write a little description. You're going to write a description of what the red line shows. So the red line shows constant velocity. We know from our Lesson 3 notes that a straight distance versus time graph means a constant velocity. And we could even give it some numbers if we wanted, but this is sufficient, constant velocity. And then how did my blue line differ from the red line? Well, as we can see, it was pretty good, but maybe I started a little bit slower, right? I was starting too slow. So I might write started slower, and then I might say, then I was matching the velocity quite well until about 10 seconds. So then I might write, at 10 seconds I went too slow, and then I sped up, went too fast. So just write a couple things here. And then you're going to click through the puzzles. So you can click this arrow here and get to puzzle 3, and you try to match it again and write the descriptions, and then you'll do all the way to puzzle 7. The next part of the lab, part 3, is position and velocity versus time graph. So here we're going to go to a different link, and this one I will open up to show you. So you'll open up to a screen that looks like this. You're going to unclick the acceleration versus time so we're not going to work with that one. So we see two graphs, position versus time and velocity versus time. Now, position versus time is the same as a distance versus time graph, so that's the same thing. And our goal is to we can move the little dots here in the velocity versus time graph, and what our goal is to make this blue line, the position versus time graph, look like the ones on the worksheet. So let's go back and see what we're looking at here. So we want our position versus time graph to be a straight line and to start at the origin, and then for every unit of time, it goes up 1 unit of position or distance, right? So for every, let's say it's a second, for every second this goes by, let's say this is a meter, it goes 1 meter. And so we see a constant slope, see a slope of 1, right? So we're going to move these dots to make it look like that. So let's go back and try that. Okay. Sorry, I'm having a hard time. There we go. Okay. I'm going to take this green dot here. If I move it up to here to a velocity of 1, after 1 second, the velocity is 1 meter per second. It's looking pretty straight, that position versus time graph, but I need to keep that velocity the same as time goes by. So I'm going to make a zero slope velocity graph. That will make my position versus time graph be a straight upward sloping line. And we know that from the lesson 3 notes, that when we have a constant velocity, straight line, we're going to have a zero slope velocity versus time graph, because this graph's the velocity. The velocity is the same at 1 second, at 2 seconds, at 3 seconds, at 4 seconds, 5 seconds. The velocity doesn't change. So then you're going to answer some questions about it. Does the object have constant, increasing, or decreasing velocity? Here in this case, we have constant velocity, right? So the first question is about the position versus time graph, and then we're going to answer a question about the velocity versus time graph. Does the object have positive, negative, or zero acceleration? So here it has a zero slope, so it's zero acceleration, right? It's not speeding up. It's going the same speed the whole time. So we will say it has zero acceleration. And then what you're going to do, you're going to go back and you're going to manipulate again the velocity versus time graph so you get a graph that looks like the one that I have screenshotted in each box. So you have to manipulate the velocity versus time graph, and then you're going to take a screenshot of both your velocity versus time and position versus time, like we did here. And here's our screenshot instructions if you need those, and then you're going to answer the questions each time. Okay, and then we have part 4. This is sketching your own graphs. So you're going to make 2 different graphs. You're going to make a distance versus time graph and a velocity versus time graph that match this little scenario here. And so you are going to, you can either use like Google Docs to make a digital sketch, and here's instructions how to do a digital sketch on Google Docs. Or if you have another program that you want to do a digital sketch, or you can sketch it on paper, on a separate sheet of paper, and just paste photos right into here. And so you'll have to, they can just be sketches. It doesn't have to be on graph paper. You can, if you want, use a, I'll put a link on here as well. You can make a graph using Desmos or Google Sheets if you want to do it that way. So this one will be a distance versus time graph, and this will be a velocity versus time. And almost always time is on the x-axis. and it will be for these ones. And so then you'll have to draw a sketch that will match this scenario. Bert is driving his car on the freeway. So first he's going to speed up while he's on the on-ramp, getting onto the freeway. Then he's driving the speed limit, so constant speed. And then he's going to slow down to get off the freeway. So you're going to draw what that graph might look like, and then what the velocity versus time graph would be. And that's it.